Hey guys, and we're back now ready to design our adapter to fit this powerboard to our pegboard. You might notice a few changes in this CAD model. So I have tweaked the cable position. If we just have a look for a second at this sort of workshop layout here that I've got, the cable that I'm doing this adapter for is going to be on this sort of right end. I'll put some mates in a second. I'll just roughly move it to position. Okay, so it's going to be around here, up the top, and the hole that the cable's coming through is actually in the middle, so it's on the wrong side for this one. But that's okay, like I've got plenty of slack in the cable, so I'm just going to bend it around and tuck it in the back beneath those keyholes. So I'm just positioning that cable where I want to hold it in the little adapter that I put together. So I have done that. And I've just grouped that in a folder. So I'm going to design this adapter in a multi-body environment, which means in this existing part file, I'm just going to keep going from here. I've already got two bodies here. I've got the main power board and the cable. Just going to leave those there and just put my adapter on the back here. That way I can get it perfectly fitting to the dimensions that I've put in so far. And then as for the pegboard's a standard sort of 1 inch spacing. The hole size I've measured around 5.8 millimeters. So we just have to design something that's going to hook into those and sit on the flat back. So I'm going to try and talk you through some of it as I'm going, but not the whole thing. So there'll be elements of time lapse here. And if I'm talking garbage, I might just time lapse the whole thing. But let's see how we go. First, I'm just going to get the position right. Now, that hole, whether I'm above or below a little bit doesn't really matter. I think I'm going to go for sort of this position, maybe the second row down from the top. Really, I just need to match it relative to some of the pegboard holes. Let's do it in between two rows because I think that's a reasonable idea. To do that, I'm going to use a front plane mate, and I'm just going to add a sketch into the assembly just to act as a bit of a guide. Okay, so we're going to use the front plane, hole control, select that midpoint, and where's it gone? It's just jumped over to the right here. That's okay. So now that's in line with that plane. Just from the side view, we'll just bring it out from the wall. Yeah, I hadn't done that right, that first one. I matched it with the point, not the line. There's a mistake. So not that point, match with that line please, that's better. And again, another mistake, should be parallel, not coincident, I think. No, coincidence, okay. There's another mate here that's wrong, this one. I don't want it right on the back, I want to bring it out a little bit because I need room for my bracket and my cable. So I do want the cable nice and snug, that looks pretty good. 7 millimeters, and then position wise, something like this. I'm just going to use that sort of top section. So what this means here is we're kind of aligning it to, you know, a set of those pegboard holes. So let's assume that cable, I've given it a bit of slack there, that bend on the end, let's assume it's going to sit here. So, you know, we might go 3 holes in from the side. That looks like a pretty good position. I've got like a mid plane here, and you can see those holes there. I quite like the look of those holes that look like they're in the middle. I'm just going to draw another sketch here. So I've just got a sketch in the assembly purely for reference because these holes are done with a fill pattern, so they don't actually have, there's no sketch or anything related to them. I could use their temporary axes, not going to worry about it. Just going to go here, get my right plane, get this point, and go mate. All right, and that's going to line up my power board nice and balanced in between. So with that done, I've now got a position for that power board, and I can build my bracket. I'm going to start back in this file and just build something to connect the back, slot into those keyholes, and to hold the cable in place. So this is going to be, I'm just done on the fly, converting that edge, give it some thickness. I'll just give it here the same thickness that I offset from the wall, 7 millimeters, and pick a distance. Okay, 80. Now we do want the power, you know, when we're plugging in, let's say we're plugging in a any plug or chargers, etc. I don't want the whole thing wobbling around, so we want to have this support at least the majority of that back section. So this one here, I'm just going to go up to this vertex here. okay? And the next one, I'm going to go up to this vertex over here. All right, that way I'm covered behind all of these ports. Now, what's important here is I uncheck merge result. Now, just kind of think about this a bit more. I want to capture that cable. That cable is 7 millimeters thick. If I have a look back at this file here and how far I've mated off the wall, I've mated like 7. So I'm not really giving much room to hold in behind it. I think I'm actually going to have to bring it out, and I think I should just bring it to around 10 millimeters. That'll give me a little bit of play, a little bit of clearance to get behind that cable and kind of wrap it in. And I'm also thinking I might move that cable up a little bit, so everything that I'm doing for this adapter can be hidden, like I don't see it dropping down beneath this point. Just get it a bit higher. So I'm going to do 2 things. I'm going to change the thickness of this to 10. I'm going to change the color of this just to identify it. Also going to change the position of the cable. So I'm just going to rotate it a bit less, and it's sitting a bit low. So I'll just reduce this number. Okay, that's better. And my body here, yep, the cable can sit comfortably in there. I'm looking happy with that. So now let's fill in the gap around it. I've got a width set, so now I can just sketch on this face, and just going to change my view orientation. So I'm a bit particular about the way I set up my views. When I drew this, I drew the whole powerboard on the top view, but when I'm mounting it on the wall, it's going to be like looking like this. So I'd like to sketch from this side view, just so I've always got the orientation right, as in this is up, going up here. I can change that. So instead of this being my top view, I can press update standard views and select front. Now when I hit like side view, it's going to show me the side view. And a little tip there. Now let's keep going with our sketch. So here we're going to assume that our radius is correct. And if it's not, we're going to find out when we do our 3D print and try fitting this. I'm going to do extrude up to surface and merge. Okay, so you can see my body there. Now I don't need this little thin bit at the end. I'm actually going to bring that back with a chamfer. So here's a little trick. If you want to put like a little cut edge on the thing there, select your chamfer, select, oh, it's too acute. It doesn't want to do it on this type of edge. So never mind that tip. Unless you just go back into the sketch, and I'll just sketch a line here, give it a dimension, 2 millimeters. Okay, that looks better. And perhaps we don't even need to go right to the bottom. If we want it to sit a little bit above, you know, instead of being tangent with that edge, we just bring it in a little bit. So where that sort of point is, just make it 1 millimeter. That looks better. Now to capture the cable, we'll just do a slot. So we're going to use this point, cut a shape like this. Cable is 7 millimeters. So we give it a little bit of clearance, we will be good. We do a cut through all. All right, so this now has a slot into it. So the idea being I'd put the cable through and then connect it into the keyhole. I will have to check if the assembly works. I think it will, because that cable can easily move up and down. Keyholes will go in the bottom and then slide up. So how do we design something here to fit in those keyholes? Here's the guide that we want to use. And this is not engineering based, it's just simple fit based. We want to use, this is our finish point here, and then the size of the pin that's going through should be smaller than this hole because it's going to sit inside it. So I'll just give it a bit of clearance. Point 2 I'll be comfortable with. Now we'll just do one of the details and then we'll pattern it across later. Okay, so that's on this face. And if I isolate this body, I measured that between this face and this face was 4.7 millimeters. We don't want to use all of that. What we might do is go offset from surface and just give it a little bit of tolerance, 0.3. Make sure it's on the right side and make sure we're merging with the right body. Okay, and then we want to give something that's going to hold. All right. Now the thing to hold is going to be on this face. So we isolate this body, select this face, start a sketch, exit isolate, turn my view around. I'm going to do a new sketch, and this one has to be smaller than this size here. So you can see the size of this one was 7.1. So here's a little way that we could do it. Let's say we want to make something that is 0.3 mil smaller. I can make this one equal to that smaller one there. And then I've got my size. Now that might be a little bit tight fitting, and we can see there's still plenty of overlap here. There's going to be like 1.2 millimeters overlap. I can show this by doing this without the line. So let's just make it a little bit easy to fit. Give it a 1 mil overlap. Okay, and then we want to make it easy to go in. So we've got all that distance that we want to hold on to. Let's select this one. Let's do a section view. Section view can come up this way. All right, you get a better idea now of where we're going with this. So we're going to extrude up. Now again, we want some offset from surface because we want to give a bit of movement back and forth so it can get in and hold without it being too tight a fit. So 0.3 looks okay, and we're going to merge it with this body. If I just bring the section forward a little bit, you can see here what we're doing. So the idea is that the key goes through the keyhole here, slides up. So in other words, the power board goes on here and then slides down into position. So it should rest here, okay, and that rest up the top there. So something else that we can do to help this process is, like for inserting it, just give a little bit of draft. So I'm going to select this face, this edge. I always do the wrong direction. Just give it a little bit of draft so it's a bit easier to insert. And I might just give that a fillet too while I'm here. All right, that looks nice and neat. Now, while I remember it, I think it's a good idea just to give this bottom line a bit of clearance, this bottom face. I'm just going to use the Move Face tool. Just give that 0.3. That'll just give us a bit of room in case we got our dimensions wrong. Okay, so it'll support it, but it doesn't need to be right up against it. All right, so that's looking good. We've got one on one side. Now, if we can remember our pattern distance here, 103.2, we can use the same pattern distance to duplicate the feature that we've just created. Now, there might be a nice way to link them. Let's see what we've got. That one there. That one is done with a sketch pattern. That's going to help. So we want to take this draft, this fillet, linear pattern. Our direction is this way. Up to reference is this way. And number is 2. Okay, how's that looking? Understand that? So the number being 2 includes the original plus the new one that we're adding. The spacing is automatic because it's just done by a reference. So we're in this direction, but this is the center point, or I could select even this one is probably better. Now, often the draft might not carry across. Sometimes we have issue with that kind of feature. So let's see. No, that works. That looks good. All right, looking really nice. Okay, so we've got the keyhole features in. We've got the basic shape. We've got the cable being captured. We would assume here that the weight of anything that's connected in this is coming down. So that force is going to keep this face close to, this edge here, and that's going to stop the cable from popping out because the cable's not going to have much force on it going the other way. We will change the shape of all of this detail later, but before we do that, what we want to do is get all the features, the functional stuff in place, and then we can pretty it up. So now let's go back to our assembly and we can just do a section view. Let's come through here. So that if we get through to where one of those keyholes is, see as I zoom in, the arrow moves. There we go. And I can save this view. So I want to come back to it. Section view, just going to press enter. Right, so we can see how that works. We want to do a similar we want to do now a hook to go through the pegboard. So typically pegboard hooks, they have like an L-shaped bend where you lift them up, you insert them, and you bend them as they come through. And that's probably going to be the best option for us. We're just going to want to make sure that our material is strong enough and the geometry of these little pegs is going to do the job. Because at the moment you can see on my top edge, it's not quite going all the way through those holes. The bottom one is, but typically you can't do 2 holes vertically spaced at the same time because of the way you need to insert a bracket, unless you have a very small hook and they're just going through and hooking down, which we could do. I'm just not sure how well they'll go with a 3D print material. That's something I haven't thought about too much. If we get all the geometry right, we can always buy a different filament and do a different print later. Right now it's all about getting the geometry correct. So which way should we go? I like the idea of going through more holes and lifting this face up, even to the point of we can't match that curve because it needs to hook down, but we can at least go a little bit higher. So I'm just going to edit within the assembly. I'm going to move that face, just get it above those holes. So let's go up 4 millimeters. Okay, that's good. And now let me show you another little trick. So we've got our position right. I'm currently editing this file because it's just a bit hard to see everything, isn't it? What I'll do is do a sketch on this face, but I'm going to convert a bunch of the holes that are nearby. And let's focus on like the middle 1, 2, 3, 4, 5, 6, 7, the middle 14 holes. So we'll forget about the 2 on the outsides. So if we have a look here, we just do a hidden view. We're just going to select those holes. You know what? I'm just going to select 2 and pattern them because I know that they are 1 inch, 7. Oh, come on. All right. So I've got the position of those holes relative to where my power board is. Now, again, this is driven by the mates. But because we made it in the right place, we should be pretty happy with that. You can see the relationship here. It's right there. I've got 1 hole too many. That's fine. These are purely for reference. All right, so let's do a little hook. The pegboard at maximum, it's like 2 millimeters thickness. So we can, if I show you this, maybe this is even a good way to do it. Convert. Just going to do it might be like 1.6 mil. A solid body here, and that's going to be my pegboard. So that's what I have to go through. So any hooks that I'm going to do, they need to fit through this space. Let's go with maximum hooks, minimum size, so we can just go straight on and clip down. We'll test it. If it fails, then we can go for something more substantial. So my idea here is going to be design 1 hook and then just pattern it across the other 14 instances. I'm going to start with this bottom one, and my key driver for these little hooks that I'm going to do, they need to fit through the holes, okay? So I'm going to design a little round hook, keeping in mind the size of these. We'll do that trick we did before, so we'll give it a bit of clearance at 0.3. I feel like that's probably not enough. 0.4, equal size. So my whole hook needs to be smaller than whatever this is, 4.95. 5 millimeters. That means, yep, that's 4.95. Put that vertical. So like this here is my potential overlap. You know, it doesn't seem like much. I think we've got to make that bigger. And then this is the distance that it can potentially sit in that hole at its maximum. It's going to be less as it goes across, 2.5 millimeters. Okay, now what am I designing? I'm going to have, can be long. Let's do something like this. So we're going to design it in its finished position. We're going to give it plenty of clearance. I'm going to merge it and we'll just keep that showing. Then what I'm going to do is take, so again, use this profile here, that section and that section. I'm going to go from this face like that. So I can see some weaknesses in this approach, but hopefully with quantity we'll be strong enough. All right, so what this means is I lift that whole thing up, it exits out, but everything is going to be riding on. Let's do a section view to this point here. I'm just going to save that section view. So we've got this little section here that's carrying all the weight. We can make it a bit bigger, just that bottom face a little bit bigger, offset 0.3. All right, so that's a bit closer. All right, does everybody see that? So we will also get, let's put a little chamfer on the top. I think that distance is going to be okay. So let's see what this would look like. You can take 1, 2, 3, 4, a linear pattern. We're going to go by inches, and we're going to do 1 up as well. Let's flip the direction. Now, has that done the move face for everyone? 2.78. Yep. So what do we reckon? How strong is that going to hold on our pegboard? So let's just give a preview back in our assembly. This is what we'll see from the front, from the side, and then from the back. That's a pretty tight fit, but should be okay. So the way the whole thing will go together, we do an exploded view, I can show you. This is going to slide up like so, and then it's going to slide out like that. Now, 14 of those little brackets could be okay. I think it's worth trialing because it's a pretty simple solution. It means I can just go straight on. So if that's what we're going to end up with, let's just clean up the model a little bit now so we can add just a bit of design, make it look neater, cut away some material that we don't need. 10 mil radius is there. Keep the back pretty flat. Think about the way that we're going to print it, or keep that edge. Let's just isolate that. So from the front, are we printing it? We're probably printing it this way up. So it's got supports on the back. We can rip out the supports around these parts, but it's not visible. Like all the ugly stuff's going to be on the back. At least the front's nice and smooth, so you get a nice smooth face against the powerboard. I think that works pretty well. Let's add some fillets in here, and we already got one on that face. I'm not overthinking any of these. Just want to get some nice finishes. That should work okay as well, and leave the bottom pretty flat apart from that chamfer. Okay, everybody happy? I think we're looking pretty good. So let's just check how this explode would work. We will move this body because it is the one, let's assume that comes too. So this is both going to go down this way, like this, and then this body is going to move out like this, and that's how it's going to assemble, and that looks fine to me, and that would be a nice neat solution. So it should also be, it'll work on both sides. So where I've got some of these hangers hanging on the left or right, that'll work too. They'll just sit out a little bit, but no big issue there. Could I save some material by putting a big hole through this? Maybe, can't hurt. Let's just see what we've got here between like these points, like that to there. I reckon we could take out all that material, just put a couple of ribs in and still be pretty strong. 3.5. So this is just going to save us probably some time, a bit of strength. Let's put a couple of ribs in. Let's go extrude from there to there. Mid-plane. This is going to be very strong. I think that's okay. Just delete, face those. Okay, so when it does the print, yeah, it just doesn't worry about hexing those. I'm not so worried about time, it's just, yeah, bit of material save. All right, looking good. Let's print. So just slot powerboard. Now to export it, we're going to keep this body and we're going to save it. Just going to save it to, we're going to save it as, I need to create a new project for this. So workshop, powerboard bracket, okay, done. And then we'll also save the step file. 3D printing, just delete that key body, save, close, save our assembly, close. Alright, you can see the garage and the house it's going into, save and close that, and we're done with the CAD. So I'm going to hit pause now, we'll come back, look at the slicing, and see how I go with the print. Okay, so yeah, they work, which is good. Just before finishing the video, I want to summarize a few things. The modeling I did, pretty accurate. You saw the fit with the cable and the power board, nice and snug. That worked really well. And the keyhole design, quite sturdy, seems strong enough. So very happy with that. The pegboard pegs, those little hooks that go on the back, we'll see how they last over time. So far, so good, but it's only been maybe a month or two of use. No issues yet. The main takeaway from this video is when slicing using the Bambu Handy or Bambu Studio slice software, you would have seen in that earlier or the first version of the slice I did, it recommended putting it on an angle, and I was like, no, I want to set it on its back to get a flat surface. It printed fine, but I had a lot of trouble clearing out the supports, even with using a support PLA for the interface. So when I flipped that around, went back to using what Bambu Studio was recommending for the slicing, got a much better result. So that's probably the main takeaway from here, and I'm starting to use that recommended orientation for the 3D prints much more in my day-to-day work as well now. So that's working really well. Cheers. Thanks for watching this video. I hope you found it helpful and found something new to enhance your SolidWorks skills. Don't forget to subscribe to Fully Defined for more tutorials, tips and insights from a certified SolidWorks expert. Hit the bell icon so you never miss an update. If you have any questions or topics you'd like me to cover, leave a comment below. I read all comments and love hearing your feedback. Remember, with the right skills and tools, you can turn your design dreams into reality. Keep modeling, keep learning, and always fully defined.